Click the bell icon to get latest videos from Ekeeda.
Up till now, we have learned about the linked list concept. Now we are going to look at how we represent in a program using Java. As you may be aware, in Java, we don't use the concepts of pointers. Pointers are completely avoided in Java. Java doesn't contain the pointers. So what are the options now? We have a reference variable. What we do is we create the reference variable of the class. Okay. Now using this reference variable, I am going to store the address of the next element. So if you will be aware that in case of linked list, we have a node which is divided into two parts, data and pointer of the next element. Now this pointer is what? In case of Java is what? Reference variable. Using these concepts, I am going to implement the singly linked list. To do this, I've declared a class called as linked list. I defined a variable called as data. Now in this, I've created a reference variable called as next. As you may be aware now that next will be a reference variable of the class called as linked list. This will store the address of the next element. Then I've created a constructor of the class linked list. Inside that, I have passed a parameter called as value. This value I will take from the user, and this value will be transferred to my data, which is the variable of the class linked list. So this dot data equal to value. Value will be taken from the user. So value will be transferred to data, which is now the variable of which class? Linked list class. So using these concepts of reference variable, I can take the values also. Okay. Now value is to be taken from the user. To take this value, I need to give some message to the user that we will say in the later part of the program, where I will be using the concept of switch cases. Using that, I will give options to the user where he can insert the elements and also delete the elements and also display the values of that particular linked list. Okay, so basically what I have done is what I have declared a class called as linked list. In that I have two variables. First variable is data. As you may be aware now, the data will hold the data values, and reference variable called as next array. Now this next will point to the next linked list. To take the values, I have used the concepts of constructor, linked list int value, and value is given to the this dot data. That is, I am transferring the value which is taken from the user to the variable called as data. After that, I have called a function called as display. In that, I will display that particular data value. So to do this, what I do is system.out.println, and inside round brackets I will write down the data. So whatever data is stored in your node, that is displayed to the user using the function called as display. I have declared a class called as linked list. Then in that I have used the variables of which class? Linked list, which I have created previously. In that we have two variables, that is FST node. Now this will be FST node will be first node. Define first node, and last node variable will be declared by the last node variable. This will define the last node. Now I've used the variables of which class? Linked list class. Okay. Then I've created the constructor called as linked of this class. First, now starting value will be obviously will be null. So the first node is also null and last node is also null. Now we need to give the values to the linked list. To do this, I will be calling some different functions. Starting, we have to give the node value as null. You may be aware that null defined doesn't. Null is what? End of the linked list. So for starting part, what I will doing using constructor concept. Okay, first I will giving the FST node, that is first node, as null, last node is also null. So we are done with the basic of nodes. Now I will be asking the user to insert the values into the linked list. To do this, I have defined a function called as insert node. Insert node will create a linked list. Okay, up till now I've just created the node having the values. Okay, now using insert node, I will be taking the values from the user. First, I will be taking the value through the user in a variable called as value. Okay, now this value will be passed to the node. Now this node is the object of which class? Linked list class. Linked list class object is node. Value will be passed through the node. Okay, now node is taken, value is given to the node. Node consists of two parts, that is node consists of data and the next element. So node will be consisting of two parts, data and next. Okay, now data is what? The value I passed on, and next is for the first node, it will be equal to none for the first node. Okay, like this I have defined the nodes. So basically we have a node having value and new pointing next pointing to none. Okay, so I will check with the FST node. FST node I will check equal to none. If FST node, that is first node, is equal to none, so I start comparing if is it equal to none. Okay, if it is equal to none, in that case what I do is what? First node will be equal to the last node and is equal to node. So the value of node and the first node and last node are kept similar. So the first node will be having the node value and it will be the null value. Okay, so if FST node is equal to null, that is taken first one. Okay, in that case if FST node value is equal to null, in that case what we do, we put the value of FST node equal to last node is equal to node. That means we have created the linked list successfully. This is the condition that node 1 is created. Similarly pattern, I can create the node 2 also. Okay, now consider a case where I will be going to the next part, that is first node is not equal to null. It means there is another node also called as node 2. So I will be going one after the another. In that case I will move to the next part. So we take if FST is not equal to null. Up till now we have learned how to create the linked list successfully. In this case what I have done, I have taken the first node, last node and kept its value as null. So my first node is also acting as the last node and that value will be pointing to the null. How do you know that it is the last node? That is, you know, it's pointing to the null value. This is how I create the node in a linked list. That I can say linked list is created successfully. But this linked list consists of only one node. If I want much more number of nodes, in that case I need to shift the pointers. That is, I need to point to someone else. In that case what happens, my first node value, okay, this will be not equal to null. So my if condition FST node equal to null will not hold true here. In that case it will move to the else part. It means that I have more nodes to add to the linked list. Now in this case what happens, if we come here, if FST equal to null, this condition does not hold true. So I move to the else part. Else part, last node next will be obviously pointing to the current node. So I need to transfer that value to the last node. So how do I do that? Last node equal to node. I write down the statement last node equal to node, and this is used to get the pointer value. Node equal to last node. So my last node value is pointed to the, now transferred to the last node. So I write down the statement system.println node inserted successfully. Like this I can add many more nodes into the linked list. So my linked list is now consist of n number of nodes starting from your FST node and going up till the last node variable. Okay, so the last node will obviously point to the null value. That means my linked list is now going to be completed. This way I can add nodes into the linked list whenever I want it. Okay, now we have learned with how to insert the node into the linked list. Now let's consider the case where I need to remove some nodes from the linked list. To delete a node from the linked list, I've defined a function called as delete. Okay, now in case of delete, I need to have the count of the nodes, number which is stored, and also the variable called as I to get the value where it is stored, that is we can say position. So I have defined three variables: count equal to 0 to get the count of the nodes of the variables in the linked list. Then I have defined the number and I for iterations. I have defined the node and node1 as the reference variable of which class? Linked list class, which I have created previously only. Okay, then to take the input from the user, I've imported the package called as java.util. In that, I'm going to use the class called as scanner. You may be aware now, I'm going to declare the variable of the class scanner and using scanner class object. Okay, now using scanner class object, I'm going to take the value from the user and that particular value I'm going to use it. Okay, so scanner input equal to new scanner system.in. Using this, I can take the input from the user. Okay, then I will be checking for the various conditions. What can be the conditions that where I'm going to check is that whether the node which user wants to delete is the first node. Then what can be the next condition is that the user wants to delete the node which is at the last, that is last node. And the third condition will be what? It will be in between, that is it can be between first node and last node, that is at the random position we can say between the first node and the last node. So I need to get that particular position also, and based on that conditions I will be deleting. So there are going to be three cases. First is the I'm going to be trying to delete the first node. Next will be I'm going to delete the node which is in the middle of the linked list. Okay, middle or any other position of the linked list other than the last node. And last will be what? Last condition is that I'm going to delete the node which is at the last position. Okay, so using this I'm going to implement the concept of deletion. I'm going to use for loop. Okay, now for node equal to fst node, I'm going to check value. I'm going to start from the first node. So the first node is value transferred to the node. Then I will check node not equal to null. Why do I do this? Node not equal to null, so that I get the condition that it is not equal to null is that it is not the last one. You have to be aware that where do you find the null value, that is how do I get it is the end of the linked list is that when I get pointer equal to null value. That's why I'm taking the condition node not equal to null. It means there is value stored, there is some node which is present here. Okay, so I start my iteration for node equal to fst, that is the first node. Then I will move till node not equal to null. Okay, and then I will be implementing the next condition. Just like in for loop we have increment and decrement to move ahead and move to back. In case of linked list I move ahead using node equal to node dot next. Using next I can move to the next node of the linked list. Okay, so I will be starting from the first node. I will be checking the condition it is not equal to null node, and I will be moving iterating through node equal to what? Node dot next. Using this concept I will first take the count of the nodes which are present in the linked list. To do this I will check the functions node equal to fst, node not equal to null, node equal to node dot next. Till there it is going to increment the value of variable count plus plus. So count will be acting as count equal to count plus 1. I am going to start with count equal to 0. If first node is there, I will take 1. Then it will be 2. Then it will be 3. Like this the value will be going on. Okay. Once we are done with this one, then I will call the function called as display. Okay. Now you may be aware display, as the name suggests, is going to display the values which are stored in the linked list. In other words, I can say it is going to display the nodes which are stored in the linked list. Okay, then I need to make the values. Okay, what I do, I will take the node value equal to node 1, which is equal to your first node. I have used the variable node 1, which is the reference variable of linked list. Okay, node is also a reference variable of linked list class. So I make first node value point to equal to node 1, which is going to point to what? Node. So all these are going to have the same value. Okay, then first I need to display to user what numbers are available. So using these concepts, I can give user much better output. Okay, so I take the value system.out.println count. Count has the number of nodes available values. Okay, so I write down system.out.println count nodes available here. This is taken from the node count variable. Okay, so count variable give me node available here. Okay, so user has the answer that this many nodes are available, 2 3 4 5 6, whatever the user has entered previously, that many node values are available here. Then I will ask the user to delete that particular node. Okay, to give this, I take the system.out.println, enter the node number which you want to delete. I will be taking the position where the user wants to delete that particular node. To do this, what I write, system.out.println, enter the node number which we want to delete. Now using integer.parseInt, I will take the input and convert into integer. Input dot next line. Input, you may be aware, is the object of which class? Scanner class. So input dot next line will take the input from the user and pass it on to the variable called as number, which is a variable of which class? Which is the variable here used. So okay, number equal to integer dot parseInt, input dot next line. So input is taken, it is converted into integer and passed into a number. So number is what? A option which the user chooses. Okay, then I will check out the conditions where you want to delete. To check out that conditions, I am going to make use of if loop. Okay, now if number not equal to 1, that is the node number. Okay, number is here your node number which user wants to delete. So if number not equal to 1, okay, this condition holds true. Then if number less than equal to count. So count is what? Is give me the number of nodes available in the linked list. I can only delete if there are obviously nodes present. If count is lesser than number, what happens is that I have no nodes to delete. Okay, let's take an example where we have node equal to 0 and I'm taking number equal to 2. Count is 0, that means nodes are not available and user wants to delete 2 nodes. So it is not possible condition. In that case, it is not going to be an easy answer to delete the nodes because there are no nodes to delete only. So I check the condition if number less than equal to count. So I will hold this condition true till we get number less than equal to count. It might be a condition where number is equal to count. Let's take an example, I have a one node only and number user obviously going to delete is 1 only. So in that case, number equal to count is going to hold true. Okay, so if number less than equal to count, then I will move to the next condition. In next condition, I will not start from I equal to 1. I will start from I equal to 2 because I equal to 1 I have taken for insertion. Up till now, we have taken the number node which user wants to delete. Now we will go into checking the condition. Okay, if number not equal to 1 because 1 I have kept for insertion. Okay, if number equal is less than equal to count, in that case what I do, I move to the for loop. So I start my value for I equal to 2. I should be less than equal to number. Okay, so I will be iterating through 2 to number the user wants to delete. In that case, what I need to do is I need to transfer the values. Now values is what is stored in the node. So node next would be transferred to the node. Okay, so for I equal to 2, I less than number holds true, I come inside it, node next would be moving to the node. Okay, then I increment the value of I will check the condition if I is less than equal to number, again true, then I will move node dot next equal to node. There will be some point where this condition won't hold true when I is greater than equal number. In that case, this condition won't hold true. Okay, so I've shifted the node dot next to node. Okay, Now what I need to do is to shift the first node, that is node number 1. Again I use the same concept for I equal to 2, I less than equal to number minus 1, because I need to make the last number minus 1. Whichever user deletes that particular previous that, it needs to be made to the node number 1. So I write down for I equal to 2, I less than equal to number, that is the user node number which he wants to delete, minus 1, which is the previous value. I put it into the node 1. So node 1 dot next will now become node 1. In that case, I need to transfer entire value, that is I need to make the pointer also shift. That is what the address also need to be shifted. The reference variable values also needs to be shifted. So I write down node 1 dot next equal to node dot next, that is this value which I have taken. So last value is transferred to what? Node 1 dot next. In this case what is happens is node dot next is transferred to node 1 dot next, and here node 1 dot next value is transferred to node 1. So I can now safely delete the values. So I've transferred the values. Now node dot next will point to what? Null. So I need to make node dot next equal to null. So node now becomes the value null. Now there may be conditions where I enter the value that the user wants to delete which doesn't exist node. So if condition I to check, if that is not going to possible, I go to the else part. So in that case I write down invalid no number. Okay, there might be case where I have only 3 nodes and user wants to delete the 5th node. So invalid is going to be the true condition. So I write down the else part, system.out.println invalid node number. Now next will be what? I need to delete the node, I need to transfer the values. So in that case what I done is the else part, that is if number not equal to 1, that else part. If I check the condition, if number not equal to 1, that is if part. Then I move to the else part where number will be equal to first node. Okay, so else part is there. In that case node dot next will be pointing now move to the first node, and node value will be taken as null, which is what I need to delete the first node. Okay, so in that case node dot next will be transferred to the first node, null will be transferred to the node, and once this is done I can successfully say that node has been deleted. First we will look at how to insert a node into the linked list, and then we will look at how to delete a node from a linked list. To do this I have defined a class called as linked list. Then I have taken a variable data, and I have taken a reference variable called as next, which is the reference variable of which class? Linked list. Then I have taken a constructor. In that constructor I am taking the value from the user, and this value is passed to this data using this dot data. Okay, so the constructor is taken and in value is taken from the user, and value is transferred to the variable called as data, which is a variable of linked class, using this dot data. Then I've used a function display to display the data. So the whatever values are there in data are going to be displayed in the user. Okay, then I've defined a class called as linked list. In that I've created 2 nodes variable, that is first node and last node. These are of which one? Linked list 1. Okay, then I've created a constructor called as linked list. Okay, so we have created a constructor called as linked, which is a constructor of which class? Linked class. Now I will initialize the value for the FST node, that is your first node and last node. So FST node, that is your first node, is going to be first time null value, and obviously last node will obviously value given null. So FST is equal to null and last node is also equal to null. So for the time being what we are going to do is what? We are keeping first node value is also null and last node value is also null. After that I will start inserting the nodes. So what I'm going to do is what? I'm going to keep first node null and last node is also null. Then I will start inserting the values. Okay, so first I will try to create the node. To do this I have created a function called as insert node, and then I will be taking the value through the user using a variable called as value. Okay, this value will be transferred to the object of which class? Linked list class. In this case I have used the object called as node. Okay, and as I mentioned earlier, in case of linked list, we have the values in form of nodes which consist of two parts, data and next. So for this node to create, I've kept node.next equal to null. What it means that first node is going to be created. So obviously now in this case, since first node is created, this will only act as a last node. So I'm keeping first node, that is node.next equal to null. Okay, then I will check if for fst, that is your first node, is equal to null. Okay, what it means is that your first node is also acting as a last node. So we are writing fst equal to last node equal to node. So the value of node is given to last node and is also given to the fst node. So what it means, we have created successfully the linked list of having only one node. So now up till now what we have done is we have created the linked list, in that we have created one node. Now suppose I need to add the nodes. It is not going to be so easy, that is it is going to be take a lot of values to be inserted. So what I need to make sure is that I shift values properly. Now how do I understand we have came to the end of the linked list, is that whenever I get node.next, that is last node is null, so it means we have reached the end of the linked list. Okay, so let us assume a condition where we are going to insert the values into the linked list. That is, I want to create many nodes in the linked list. In that case, obviously my first node will not be equal to null, so my if condition won't execute here. Okay, so I will move to the next part, that is else part. In that case, what happens is that node value which I have taken, node, okay, that will become my next. So last node dot next will be equal to node. Okay, so that reference is passed to the last node, and then I will be taking the node value. Now node is going to be transferred to the last node. So my node value are going to be stored into the last node variable. Once I have done this, it means I have created the node successfully. Okay, so before, if fst equal to null, it means we have created the linked list successfully. Any other conditions where last node equal to some node value, in that case means that we have created the node successfully. Then we are going to create a class called as singly linked list. Okay, now in this class I'm going to create the objects and taking the value from the user through the switch cases. Now I will write down the class singly linked list. Then I've created a class object called as list of which class, linked. Okay, now clear properly. I've created the object of which class, linked. Now to take the value from the user, I've taken a class called as scanner. I've created the object of this scanner class named as input. In this input I will take the values. Then I will check with the operations. I've given the operation as 1, 2, 3, 4. 1 is for insertion, second is for deletion, third is for display, and fourth is for exit condition. So I will check that value, I will take value and put it into the OP variable. Using switch case, I will check their particular condition. So condition number 1 is for insertion, condition number 2 will call for deletion. So let's look at the example now. Now user is provided a menu driven program where he is given a number of choices to choose from. 1 is for insertion, 2 is for deletion, 3 is for display, and 4th is for exit. First he will be given the choice, so user needs to make sure he enters the proper choice. So let's take an example where he wants to insert. In that case he will choose the choice number 1. So he is telling the computer to insert the values. So we have the value chosen as first, that is insert. Then we need to have the position of the value of the linked list. Okay, so I need to take the value from the user. Let's take an example where user wants to enter 10 into the linked list. Okay, so linked list is created successfully because this will act as the first node and it will also act as a last node. So we have a 10 value inserted into a linked list. So I can say successfully we have created linked list. Then again he will be provided with the choice. Okay, he wants to insert the elements much more, that is he wants to create many more nodes, so he is going to choose the choice number 1. Then we are going to insert the values. Okay, that is here we are going to insert the value called as 20. It means we have created the node successfully. Again, user wants to enter the choice. He going to take the insert value, that is choice number 1. Then he going to insert the position of the linked list. In this case, we are taking the value as 30. So again, node is created successfully. Okay, so we have entered how many values till up till now? 10, 20 and 30. Again, we will enter one more value. Okay, let's take example, we is entering the value 40. So we have values 1, 2, 3, 4 as menu driven, and in that value using we have inserted the value 10, 20, 30. Now let's take a case where user wants to delete a particular value. To do this, he needs to make sure he chooses the proper option. Now in this case, we have the option called as 2 for deletion. So he enters the choice 2. So list of nodes will be first displayed to him, that is 10, 20, 30 and 40. These are the 4 nodes which are available to the user. Now out of this, user needs to make sure he enters the proper node to delete. Let's take an example where user wants to delete node number 30. Okay, in that case, node number position is what? 3. Okay, so we have 3 number position node. So we are giving that node has been deleted successfully. Clear? Now we will look at the value where we're going to choose the option number 3 to make sure the values are displayed properly. Now look at the list of nodes. We have 10, 20 and 40. So node number 30 has been deleted properly. Here the important point is that you enter the proper position of the node. If you misplace the position of the node, you won't be able to delete the values. Thank you for watching this video. Please subscribe to Ekeeda channel.